Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi and we continue with our topic of discussion, and the topic is structure and bonding. So far we have already discussed ionic bonding. We have used dot and cross diagrams to illustrate ionic bonding, and we have also discussed the giant ionic structures and the properties of ionic compounds. So we are going to discuss the second type of bond, and this is covalent bond. So our number 2 is a covalent bonding, and we can say that covalent bonding is the type of bonding that exists between two or more nonmetals. Is the type of bonding that exists between two or more nonmetals through sharing of electrons, through sharing of outermost electrons. So we can say that this is the type of bonding formed in two or more nonmetals. So this one is commonly nonmetals only. Nonmetals through sharing of electrons. And on this we'll find that for those nonmetals that do not have a stable electron arrangement, they can bond together by sharing their outermost electrons in such a way that they gain stability. So they gain stability by sharing electrons amongst themselves. So here there is no transfer of electrons. There is no loss or gain here, but there is sharing of electrons. And we can say that when sharing of electrons is done between a few atoms, this constitutes a molecule. So if there is sharing of electrons between just a few atoms, not a very big number, then we have a molecule. So we can even define a molecule and say that a molecule is made up of two or more atoms of the same or different elements. A molecule is made up of two or more atoms of the same or different nonmetals bonded covalently, or having covalent bonds between them. Two or more atoms of the same, they can either be the same or different nonmetals, but they must be bonded covalently for them to constitute a molecule. I want us to take an example of a hydrogen molecule that is written as H2. And that hydrogen molecule, or H2, is made of two hydrogen atoms. So two hydrogen atoms, when combined together, they form a hydrogen molecule. So in this, assuming that this is a hydrogen atom has only one electron. So if you combine it with another hydrogen atom, also with one electron, is a hydrogen atom, another hydrogen atom. So we are saying that a hydrogen atom has one electron. So it is not stable. It needs another electron so that it can attain a duplet. An electron arrangement of 2 is what you are calling a duplet, which is stable. The other hydrogen atom, the same. It has only one electron, so it is not stable. It needs another electron. So what will happen is that the two atoms will come together and then they will share the electrons. So they will share the 1, 2 electrons so that they attain a stable duplet. So in this case, they will come together and they will overlap. They will come together, overlap, such that the 2 electrons that were there, they are shared between them. So that this atom is stable because it has 2. The other one is stable because it has 2. So that's what we are calling through sharing of electrons. So it's through sharing of electrons. So whatever has been formed here is now a hydrogen molecule, which is H2. It's H2 because it's made of 2 atoms. Then where is the covalent bond? The covalent bond is where the sharing is happening. So that is where the covalent bond is. The covalent bond is where there is the shared pair of electrons. Where there is a shared pair of electrons, there is a covalent bond. And this one can also be represented as H, covalent bond H. So that's a covalent bond. And in that we can say that wherever there is a shared pair of electrons, wherever there is a shared pair of electrons, it constitutes a covalent bond. If there is only one pair, that's one covalent bond. If there are 2 pairs, those are 2 covalent bonds. So here, there is only one pair of electrons, and that is what we are indicating as a covalent bond here between a hydrogen and another hydrogen. We can also have another example of oxygen molecule, which is the same as oxygen gas, and this is O2 . And that is O2, and this is made up of 2 oxygen atoms, an oxygen atom and another oxygen atom. So here there was one electron in each. So oxygen molecule will have an oxygen atom O. An oxygen atom is 2, 6, so we only show the outermost electrons here. 1, 2, 3, 4, 5, 6. Only the outermost electrons are shown because they are the ones used in bonding, the valence electrons. So we have plus another oxygen O. 1, 2, 3, 4, 5, 6. So this is also O. 2, 6. So we are saying that this oxygen atom needs 2 electrons here to be stable. This one also needs 2 to be stable. So the 2 will come together and they will share. This one will share 2 with this, and this one will share 2 with this. so that this one gets the 2 it needs and this one gets the 2 it needs. So the diagram will be as shown. So you'll have O and O. That's the oxygen. So we are saying that each will bring 2 for sharing. So that means 4 electrons will be shared, 2 from here, 2 from there. And then the remaining unshared will be 4 because only 2 have been shared, leaving behind 4. And the other one we are left with also 4. So 6 minus 2, you get 4. So the minus 2 is the one that has gone into the sharing. So if you count the total is 8. 1, 2, 3, 4, 5, 6, 7, 8 for this one. And for the other one is also 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is now the oxygen molecule, which is O2. And there are 2 pairs of electrons shared. So these are double covalent bond. So these are double covalent bond. So every pair 1 bond, every pair 1 bond. So this is O, O, and then 2 covalent bonds. That's the way to show that. So a point to note on the oxygen, or a point to note when illustrating covalent bonds, we only show the outermost electrons. We only show the outermost electrons because they are the ones involved in bonding. They are the ones involved in bonding. So that's why we are saying that we only show the outermost electrons. We are not showing the 2. We are showing the 6. We are not showing the 2. We are showing the 6. The 2 is never affected. It's already inside there. So at that point, we'll have an assignment. So the first question, using a dot and cross diagram, show bonding in A, nitrogen molecule, and B, water. And then question number 2, what is covalent bonding? What is covalent bonding? So we'll stop there until the next lesson. Goodbye.